Hello all. I am sure that you have checked the videos of type inferencing, type class, and you have also seen the video on how to develop a function. In this video, we are going to talk about specifying types while writing a function. So let's log in into the interpreted mode, and there are a variety of functions which are built in. Like we will start with equality function. So if I say 1 compared with 1, then it says true. If I say 1 compared with 2, then of course it's going to say false. We can check the type of this operation by passing it into rounding bracket, t colon rounding bracket, our function. Then it says that double equal to is in a function which has equality type class of input A, which is a type variable, and function accepts two arguments and returns a boolean result. Now this equality type class can represent anything that we can compare. So what exactly I mean is, if I say 2 is equal to 2, it says true. Here 2 represents a numerical data. Can we use this equality for character data? Let's try. So single quote A compared with single quote A. So again it works. So here equality is a type class which can be associated with anything which can be compared. So you can use this equality to compare list, you can use this equality to compare character, to number, to factorials, any type of data which can be compared. Let's say we want equality function which works only on numerical data and nothing else. So this is not satisfied this default comparison operation available in Haskell. It is supporting everything. Now let's try to define a equality function which will work only on numerical data. So let's open up a notepad. In this file we will write a equality function of our own. So let's call this function as myEq. Let's refer how Haskell is defining its own function. So see, if you are type checking the function of equality, it says that this is the function name, then has type class, this is the type variable, then number of arguments and return type. So we will follow this exact signature while defining our own function, but rather than using the equality class, we will use a class which can use only numerical data. So let's do it. So instead of using double assignment statement, I am saying that my function name is equal, myEqual. Then we have a colon. Now EQ, if I use EQ, then it will again support everything. Instead of that, I can use int, I can use integer, or I can use fact, I can use real fact, variety of numerical type data available. Integral type of data in Haskell represents a whole number. So let's use integral data in this example. So integral A. So what it says is my equality function has integral type of data and type variable is A. Now I can use this A. So this is my argument and I'm going to return a value of type boolean, which is true or false. I need two arguments to compare. So let's read out what is this signature mean. Function name has integral type data. A is a type variable. This function is going to have two arguments of type A, and A is of type integral, and it's going to return a variable of type boolean, or the value of type boolean. Let's write the definition. My equality function given with two inputs, let's say T1 and T2, is going to work like this. So assignment starts with definition. So my equality function input or type input 1, type input 2 works with if T1 is equal to T2 if t1 is equal to t2, then true, else false. So let's save this file. File is saved. Now let's try to load it. The file name is eq and my function name is myeq. So let's try to load the file, :l eq. So the function has loaded successfully. Now let's try to execute it. myeq 1 So it worked. It says true. Now let's try to use myeq to check a character data. A compared with A, and it do not work because myeq is strictly defined to work with integral data. So here you can say that no instance for integral char arising from use of myequal. In my expression myequal A, so it clearly the error also saying that there is no instance which is working with character and integral. It is working only with integral data. So this is how we have defined our own equality function, which is going to work only with numerical or integral data and not with any other type. Let's try to write a even odd function. Let's create a notepad file. So here is our even odd file in which we'll write the program. So again, function name, let's say myeven. So myeven function will check the number. If the number is even, it will return true. If the number is not even, then it will return false. So let's say myeven function has, again, we are not supposed to check a character for a even odd or a string for a even odd. Again, we are supposed to check only integral data, whether it is even or odd. So I'm again going to make use of integral here, integral A, and now this belongs to A is an input. This program is going to take only one number as an input and check its polarity, even or odd, and then return a boolean value. If it's even, then it will return true. If it's odd, then it will return false. So we know that myeven, I am sure you are able to recall from our earlier discussion about one mod function. Let's try that in the GHC environment. So let me come out of that, clear the screen, and let's start again. So if I say 1, then inverted commas, mod, this inverted comma is at the tilde symbol, take care of that. Mod 1, inverted comma available at a tilde symbol, which is before digit 1 on the keyboard. So 1 mod 2, so result is 1. 1 mod, let's say 2 mod 2, result is 0. So 4 mod 2, again the result will be 0. So we know that if we mod anything with 2 and if the number is even, the result is going to be 0. If the result is non-zero, that is 1, then the number is even. So we can use this formula in our function. So let's write myeven. Let's say it accepts a number n. Then what it does? Let's say if n is mod with 2. Now this function is going to return a result which again we should compare with our own expectation. Let's say equal operation 0. So if n is mod with 2 and if the result is 0, it means the number is even. So true, else the number is false. So let's save this. Now file is even odd and the function name is myeven. So let's try. So :l even odd. Sorry, I should. Okay, there is error. Let's solve. So what's the? I'm missing one bracket. Let's go to the program. So a bracket of if and the bracket of formula. Now let's try to save it. Let's go back to our environment and try to load. So program loaded. So let's clear the screen before execution. GHCI l : even odd. So loaded, and now let's my even is the function name 2. So it says true, 1, 2 is a even number, 3, false, 4, true, 5, false, 6, true. You can hard code some of the inputs if you want. For example, let's go to our notepad file. In here, what we can do is, if my even is given 10, then if you want, you can specify a boolean value. Let's say I will print true. So my even, if it finds that the input is exactly 10, then it will directly go and print true. It will not go with the actual checking. So let's try. Let's load the function again. Load function loaded, my even and 10. Now in this case it directly said true. How we can verify whether it is directly returning or it is calculating and then returning? Let's do one tricky task. I'll say 10 is false. Now we know that 10 is an even number, so if we mod 10 with 2, the result is 0, and obviously the function is expected to return true value. But what we are doing is we are hard coding a choice, my even 10, and we are saying it's false. So it's an exception. So it's an exceptional condition that my even function is not going to give a correct result for value 10. So let's try. So can you see this saying false? So this is how you can give some hard coded values for a that will not need a computation. It is better useful, like 0 is not even, neither odd. So I should return false if somebody gives 0 as a checking input for my program. So let's reload the program. GHCI. So L colon L even odd. Okay, L colon even odd, and then my even 0. Now it says false, and now it should give correct output for 10, which is true. So this is how you can use hard coding of some of the conditions to give the exact result. So now let's try to write a factorial function without using product operation, which we have recommended in the earlier videos. Instead of using product function, we will try to write our own factorial function. So let's do it. Let's create another notepad file for that. So I'm going to call this file as fct. So let's call the function as also fct, fact, or let's say fact is a function. Now again, we can't calculate a factorial of a string or a character data. We can calculate a factorial of a number. So again, let's say it's a integral a has one argument which is of type a, and we know that now a is not going to get type infer. It knows that a is of type integral, and it's going to return a, which is again an integral type of a data. So here our function is accepting both data as a as well as it is returning data as a, which is a type variable. And what is the type of this variable? Type of this variable is integral. So it's not going to infer at a runtime. We know what is the type of a at a compilation or at the writing of program itself. So let's say fact of, let's use hard coding that we have just seen in the even odd. Factorial of 0. What is the factorial of 0? Let's say 1. What is the factorial of 1? Let's say 1. Now if anything other than 0 and 1 is going to come, for example factorial of n, then we have to write a program now. So what is the factorial of n? We know that the factorial of n, there is a formula that factorial of n is n into factorial of n minus 1. So we are directly we are performing a recursive call here. So let's save this and try to load it. So let's go to our GHCI environment. So colon L, so loaded, and the program is fact of 1, 1, fact of 2, 2, fact of 3, 6, fact of 4, 24, fact of 5, 120. So it's working perfectly. So let's try to clear the screen again. Load GHCI colon L fact.hs. Now factorial of 0, 1, factorial of 6, 720. So it's calculating the factorial of numbers. So we have seen variety of operations, but mostly we are returning a boolean. We have checked how to return a boolean. We have checked how to return a number. Let's check how to return a string. So what we can do is, or a string or a list. I am sure that you are able to recall that string is nothing but a list in Haskell, right? So let's return a string now. Let's create another notepad file. uh, I'm going to call this file as combine.html, and I'll write a program which will combine two characters to create a string. So objective is clear. We are going to write a function called as combine, which is going to accept two characters. Now see, characters, and then what we will do is we will write a function which accepts a character and returns a string which is comprising of repetition of that character. So let's say we know that our function is going to have a variable of type A. Now here we are not using integral or a string, we are using character data. Now this function has one input of type A and it's going to return string. So we can we can write anything as a definition for this now. So let's say n is a character given, and what we will do is we will say we will create a list n comma n. So here what we are doing is we are taking one character as an input and we are creating a string which is repeating that character. So let's save this and let's try to load this function into our Haskell environment. So let's go and let's try to load this function. So :l cmb. So loaded. Oh sorry, cmd I've typed cmb, and there is one error, says cmb lacks an accompanying binding. So let me solve this. Okay, so instead of using this type of binding, what we can do is we can directly say the input will be of type char and the output will be of type string. There is no need to use the brackets while binding the type variable and the output. And this is B. Let me save this, and now I think it's okay. Let's try to load again :l cmb.hs. Okay, the module got loaded. So let me clear the screen. ghi l :l cmb, and now whatever we pass to cmb, it will just repeat it. Oh, I have to pass a character data, so not a numerical. So 1, so it is creating a string of which is 11. So if I say cmb, let's say a, then it will pass. Oh, I have to give it everything as a character. I can use even a string. So character AA. So cmb is going to take accept a character as an input and return a string as an output. Hopefully you got the concept of defining functions and performing type inferencing at a definition of a function itself. We have seen various functions like checking the equality, checking the even odd, factorial calculation, and now creating a string. In these all different functions we have returned a boolean value, we have returned a numerical value, we are returning a string. In this case we are returning like now we know how to return a boolean, we know how to return a string, we know how to return a list, we know how to return a particular number, and we also know that how to hard code the result if we want. We have seen this in a factorial program. Hopefully this will help you in understanding functions in a better way and type inferencing in a better way. See you in the next video, and we will talk about functions again. Thank you.